Hi, my name's Brandon Anderson, and I'm a student at GCU. And this presentation is for ITT-316 with Professor Tim Collins. And today we're going to be doing a traffic analysis with Wireshark. And so first, what we want to look at, today we're going to be looking for some very specific pieces of information that are contained within this traffic analysis. So here in Wireshark, we have something called a packet capture, or a PCAP as it's known. And in this capture are frames or packets of information. And this is captured as it goes over a network. And these can be looked back at or analyzed for security purposes, troubleshooting, tons of different reasons. But first, what we're going to do, we're going to go to frame 8 here. And as an example, what I want to do is we're going to go to IEEE 802.11 data. I'm going to click here. So what we're looking for here are the source and the destination MAC addresses, media access control. So source we have here, Gemtech Technology, and destination have ASCII computers, I believe. And so these MAC addresses, very important for layer 2 of the OSI model or the data link layer. And they're used to identify the sender and recipient of frames that contain IP packets, similar to the physical address written on an envelope. Okay, now if we look at the Internet Protocol version 4 field, so what we're going to do here is we want to identify the sender and the recipient IP addresses. So if we look here, transmission control, oops, here we are. So source address 192.168.100.51. This is the sender. The destination 192.168.100.52. And so right here, these two individuals are on not only the same network, but the same subnet. And this could be the computer across the room or just very close on a similar network. So contained in this layer are the source and the destination Internet Protocol addresses, also known as IP addresses. These are a logical address, which is essential for routing, and routers use these addresses to send and receive network communications. The network layer contains a logical map of the internet, which connects devices across the entire globe. Essentially, layer 3 is paramount for network communications. Next, if we look at the transport control protocol field, we will see that the data contained in layer 4, which is known as the transport layer. Layer 4 is responsible for the transmission of data, and the two most common protocols on layer 4 are the Transmission Control Protocol, TCP, and User Datagram Protocol. On this layer, features for transporting network communications, such as segmentation, flow control, reassembly, and sometimes even error control, are handled. Sometimes to effectively transmit large amounts of data, transport protocols such as TCP break data down into smaller chunks called segments, and this is known as segmentation. After the segments arrive at their destination, the transport layer is responsible for reassembling the data to the recipient for access. One of the most important elements of the transport layer are ports, and these are essentially pathways for data to be sent and received. There are 65,535 ports for both TCP and UDP, and in this specific frame, the sender's source port is TCP20, which indicates FTP usually, or file transfer protocol, and the destination port is 1105. Essentially, The transport layer is responsible for how data is handled as it is sent and received. And now that we've looked at the source port and the destination port, let's go look at what kind of data could be carried here. Now, this specific frame isn't carrying any kind of unencrypted data. So if we go down here, this is data contained in the application layer or layer 7. And these are the times that try men's souls. Kind of a funny little nod to how it may feel sometimes analyzing traffic. But either way, there's the application layer. Now, let's travel down to frame 136 and look at the IEEE 802.11 data. We can see the source and destination MAC addresses. So look very closely. Got the receiver, the transmitter, and the destination. So from source, destination, we've got ASCII computers and Gemtech technology. Now, the interesting thing about this specific frame, because this is encrypted 802.11 data frame, the IP address in layer 3 and TCP ports in layer 4 are encapsulated inside the encrypted data, which helps protect the sender and receivers along with the data. Because of this, IP addresses, ports, and the data contained within are all encrypted. So the MAC addresses and trailers are only visible to assist in routing. So, as an example, if we look down at the bottom of the frame and click on the data portion, we will see a long string of hexadecimal code, and this string contains the IP addresses, the ports, and the data contained in the packet.